So I'd like to finish up with our sheet 0.1, our first intro topic, literal equations. Now, I should mention, because it's completely true, this is challenging. I purposely chose a challenging topic to start with. Yes, we will be doing many other challenging things this year, but that is the point of the class, to be working on many new ideas. Now, that doesn't mean that you can't do it. I actually believe that you can do this, but if we look here at this example 3, again, it's a challenging problem. In fact, we're going to solve it for W, and we're also going to solve for Y to show that we can solve for any variable that we want. So what do we got here? X equals 8 minus Y all over WY. It's a fraction, and fractions are fun, but they can also be challenging, and it's because they have denominators. Denominators make things more challenging. Well, the first thing I want you to notice is that the numerator, it does have grouping symbols around it. The reason I say that is because now we have an inside part of the fraction. Remember, you always want to work from the outside to the inside. You actually want to kind of work that way. So I want you to notice that W is down here in the denominator, but it's part of a WY, which is actually on the outside of the equation. So that's going to be the first thing that we sort of start with, that we work with. And it's no surprise, or I shouldn't say surprise, but it's no coincidence that where we're going to start is in the denominator. It's very often what you do with a fraction, you start by doing something with the denominator. And in this case, it's this W that's down here. And since we're trying to solve for W, we need to get it out of the denominator. Now remember, because in the denominator, it's being divided. And so inverse operations would be multiply it. Can I multiply both sides by W? Sure can. It's going to cancel on the one side, but more importantly, it's going to give us a result where the W is now out of the denominator. We do not like denominators. We don't like W in the denominator, so now it's on the other side of the equation. Well, it turns out that the only thing left to do is to get rid of this X over here, and that X is being multiplied. At this point, we should be pretty confident that the inverse of multiplying is dividing. Now, when I divide X to the other side of the equation, there's no need to draw another fraction bar. That's because we already have this fraction bar right here. So I can just put the X divided by X, honestly, under the same fraction bar. It cancels on the left side. It gives us this 8 minus Y over XY. We usually write things alphabetically over XY, and you just solve for W. What if we want to solve for Y? Okay, now, first thing to notice, well, I'd say at least one thing to notice is that there's two Y's. Remember what we said? Whenever there's two or a repeated variable, factoring is on the horizon. Okay, well, before we do any factoring, we still have this denominator issue, and it's the same denominator, it's WY, but this time I want the whole denominator to multiply to the other side. Why do I want the whole denominator? Okay, just because, honestly, a little bit of insight says that if we're going to do some factoring, I need this to be, I need it to be a non-fraction, no denominators. So I'm not going to recopy it since I kind of already have it here. Let's multiply WY to both sides. Again, that cancels, gets rid of the denominator. It basically causes the WY to be now on this side. Alphabetically, WXY. Now, this gets a little interesting. but we have to keep in mind that there is a repeated variable, and it's on opposite sides of the equation. Okay, I can't factor until it's on the same side of the equation. So one of these y's needs to move to the other side. Make sure that you make your life easy. This one right here is being subtracted. It's really easy to move that to the other side. All you got to do is add it. Except when you add it, you can't do something silly like say that those y's add to be 2y. They're not like each other. So I just end up with a y that's now added to the other side of the equation. Okay, well, it's factor time. How do I know it's factor time? Because the y's are repeated, they're also together, and what I want to do is I want to factor out the y. Now when I factor the y off of wxy, I'm just left with wx. But when I factor the y off of y, I'm not left with nothing, because actually factoring is really the same as dividing. What I'm trying to say is that I really divided off of y, and that leaves me with the number 1. If you want to think of it another way, you could think about distributing it back in, and if you distribute back in, you'll be back to where you started. So we need the number 1, and we're one step away from solving for y. Do you realize that this quantity right here, this quantity is being multiplied? And the inverse of multiplying has always been dividing. Can I divide both sides by wx plus 1 as a quantity? Yes. It might seem a little strange, but your answer is going to look like y equals 8 over wx plus 1. Now, as I said at the beginning, that's not an easy problem. Do I expect that you knew how to do that before we went over it? I do not. But I'm trying to show you some skills that may allow you to get a little further, even though we're at the beginning of the year. And why don't you see what you picked up on? Let's do a practice problem. I'm going to skip P1 right now, practice 1. Let's skip to P2, practice 2. I want you to think about solving this for B. If you're in the classroom, you can talk to your neighbor about a little bit. Maybe before you jump right in, you want to notice some things about the letter B. So go ahead, see if you can solve for B. Now, some things that you might be talking about with your neighbor is that B is repeated. That means factoring's on the horizon. The other thing is that the B's are not on the same side, so we want to get them on the same side. If you're starting the problem by subtracting 5b, it's a good start because you need the b's to be on the same side. Subtracting that 5b is the easiest way. Honestly, it just keeps it simple. Now the b's are at least on the same side. As we've said a few times, you're going to factor out that repeated b. What are you left with? You're left with 2c. You're left with a minus 5. When you factor out, it's really like you're dividing it out. It's like you're doing the distributive property backwards. Now that quantity 2c minus 5 is being multiplied, so all I got to do is divide it. I got to divide 2c minus 5 to both sides. Remember, when you divide, that cancels, but it now leaves us with the letter b all by itself. It does also leave you with a over 2c minus 5. Do you remember that problem that we sort of used at the beginning of the lesson? Solve this for f. Now, if you're going to solve this for f, you're going to need to think about what to do with the fractions. And what we've done, at least a few times, is we have multiplied by the denominator. We've done that for a few situations. Sometimes we've multiplied by the whole denominator, sometimes we've multiplied by just part of the denominator. But it ends up being a good idea, at least something to think about when you have fractions. In this case, we have 3 fractions, and so we're going to multiply by, well, by all the denominators. Now, if you multiply by all the denominators, f, a, and b, all at the same time, what's going to happen here is I'm actually going to distribute FAB to each fraction. Okay, now to each fraction means to each numerator. So I have FAB all over the original F. I have FAB all over A. And I have FAB, whoops, it's not an equal sign there, it's a plus sign. And I have FAB over B. Now somebody might say, how was I supposed to know to do that? Okay, again, I'm trying to show you some new ideas, but I also want you to see the result of multiplying by the denominators. The fractions are all gone. And when fractions are all gone, our life gets a little simpler. We can kind of see a little more clearly what we have left here. Do you see? We have a repeated f, don't we? What do you do with a repeated factor, or a repeated variable? You factor. So we're going to pull out, kind of running out of space, I believe. We're going to pull out the f. We'll just slide over here. We're going to take out the f. Let me organize it the same way. And we're going to be left with a b. We're going to be left with an a. And we find ourselves in a spot we've been at now a few times. All you got to do is the inverse of multiplying, which is dividing. You always divide both sides. Although I've seen some students kind of make that a little simpler just by showing one big division sign. I'll let that go. You could do that. And you kind of are dividing both sides of the equation. It does cancel on this side. On the other side, it leaves you with a fraction. It leaves us with a final answer that I need a space to record. Let's see what we get here. You're going to have the AB that's hanging out over there now over B plus A, and that equals F. And we just solved that literal equation for F. Okay. You got some homework problems to try on the back of the paper. We certainly will keep talking about this. I expect you to try your best, as always. I think you'll find some of the homework problems be a little simpler than the last few problems we did. But near the end, you'll see some where there's some more challenge. So give it a try.